Hi there, students. Can you hear me? Just make it sure that whether can you hear me? Am I audible enough for you? Yeah, good. So I just finished one of these 2023 seminar and starting this one in the same trot. By the way, so today actually we are just going to do something called vectors. Everybody knows vector already. Even 2023 students 2024, and everybody knows this one so far. But this lesson we used to teach in some manner, slowly and steadily. Even in my regular class, I took to finish this lesson 5 days. I took some 5 days to finish this. But at that time, you were like just O levels. You done just O level and you were just stepping into the A level stream. Then I couldn't do much faster. But actual pay for this entire lesson, it would take no more than 2 days. So today, what I'm going to do is, I am going to finish this entire vector part within 2 days, entirely with all the exam questions and everything. You might be wondering how. Because we used to teach some unnecessary stuff in the first few lessons. You are now, everybody in this class, in guys in my class, as well as some other classes, in your schools even, you do something like Newton's laws, friction, momentum. Compared to this lesson, what about vectors? It's nothing. But you might be really struggling in Newton's laws, momentum. The reason is nowhere. It is this vector. If you are not really good at vectors, you will really going to get stuck in these lessons. So today I am going to teach you vector part entirely with 2 days today and the very next day. And I am going to change the order even. Normally we used to teach like what is a vector, give some examples, right? Give some examples. Then after that I take some time to explain this it again and again. And do like what? Addition, vector addition, vector triangle, vector parallelogram. Then what? Vector polygon and vector resolution. This is something else. Today I change the order because according to that order, at least we take like 3 days. It's really chaotic because you know this thing now. You have done something now. If I teach the same slow phase, you will get fed up. Actually, tell me honestly, I need your answer from honestly. How many of you guys feel really comfortable with? No, just text me if you are really comfortable with vectors or really uncomfortable with vectors so far. Just text. I can see that. Quickly, comfortable, uncomfortable, comfortable, uncomfortable. Quickly. I need to take some stat, like a consensus. Uncomfortable at the beginning. Wow. Others, I don't say your name, don't worry. The one girl said she's feeling really uncomfortable. I need to just get comfortable. Okay. I know Devmini, she's really comfortable at these things. Others, uncomfortable. Okay. Good. Quickly. Am I just comfortable, uncomfortable? Type and send me. Yeah. Our teacher didn't teach yet, sir. Okay. Others, so there might be some guys have no idea yet. I only got 4 answers yet. Uday, just ask a simple question. Comfortable or uncomfortable? Okay, I got few answers. According to that, I'm going to satisfied with myself because I know there are some introverts in this world. They are really afraid of texting something and send. So I don't want to interrupt their feelings. And so many people found it really hard. Somebody that's hard, somebody just confusing, somebody are really comfortable. Okay, good. Now I'm going to teach you because this part is really essential in all the other lessons, but easy. So firstly, I'm going to teach you what are vectors and what are non-vectors within 10 minutes. Ati, ara class එකේදී වගේ පැයක් එකමාරක් ගන්නෙ නෑ මම. I'm not taking 1 hour and 2 hours to explain like in the regular class. Then straight away, I'll go for vector resolution. You might be wondering, is he lunatic? Is he running out of mind? Yes, I did the same way for the regular class. I did firstly what is vector, vector addition, vector triangle, vector parallelogram, then vector resolution. Today, I'm going to teach what is a vector, then I'm going to teach what is vector resolution. You will see why and how comfortable it is. Then after, vector parallelogram and vector triangle. And finish for today. In the next day, vector polygon and final questions and finish this entirely. Okay, shall we take the challenge? Shall we take the challenge? Accept the challenge? Okay, so here, to explain this properly, one thing you have to know one thing, but in vectors, if I choose this direction as my positive direction, I have no other directions to change. Like this, have a good look at. That's something you have to remember during entire process. That's where you find difficulty in momentum. Imagine you have a collision of momentum. This is what MV, MU, and it collide and bounce back. With MV, if I ask you to find out delta P, normally if there are like 100 students in the class, more than 85 get stuck. They don't get the real answer because they don't have the idea of unidirection, omnidirectional. How would look at it? If I'm facing my face to that direction, I can walk there. But if I change back and walk here, it is completely forbidden. Why? It's completely forbidden. Why? Because if I selected this direction as my positive, that is my entire direction. Because vectors are all there. What is the definition of vector? I will tell you. But rapid remember. Quantities, physical quantities with magnitude and a direction. Okay. Here there might be certain magnitude, but the amount of steps I keep is the magnitude, but the direction is this direction. Once I choose, I can't turn back, but I can move while keeping my face to there, and I keep moving back in this way without turning. I have no right to turn, right? I have no right to turn. That's the first rule you have to remember. If you choose some direction, that is the direction it's going to determine your entire journey. You have no turn back. If you want to come back, you have to keep your arrow in the same direction. If this one was like P, this is going to be negative P, but your head should be kept in the same direction. Can you keep this in your mind? Then move on to my regular, what is called virtual board, because I'm not a guy who uses this type of whiteboards to explain, because in the whiteboard, I have my limitations. I can't show the collisions and do exactly neatly. But in my virtual board, I have all the facilities there. No, I didn't explain. Oh my God, I didn't explain anything yet. I didn't start the lesson. I didn't start the lesson at all. I'm just showing you the basics, right? Now only I'm going to start the lesson, give you all the definitions, right? Everything, but there is a virtual board. Let's go on to the virtual board and see it. Okay. I didn't start the lesson. I'm just showing you my day plan today and what I'm going to do. That's it. Okay. I'm going to start now at this moment, very this moment. Okay. So stick around there. You will see what is it actually. Can you see this virtual board? This is what I was talking about. Let's start the topic. Write a big topic, vectors. Write a very huge topic, vectors. And I'll give you a definition now. Vectors. Okay, I think everybody got the tune. If anybody couldn't get the tune, please drop a message to my number and ask me for the tune. This is 8763471 is my number. So drop a message and ask for the tunes if you didn't get, because I expect that everybody got the tune so far. Who knows, if anybody couldn't get the tune, just let me know. I will just forward you the lesson. Okay. Okay, Lamai. So did everybody get this tune? Did everybody get this tune? If anybody didn't, just let me know. I know most of you got the tune. If anybody didn't, I would share you the tune, because without this tune, we might not be able to continue with the lesson properly. Okay. So remember that this is a rapid revision class, not a regular theory class. So I have no time to waste here, because within 2 days, I'm going to finish this one, because this is the second batch, actually covering up between the first batch and the second batch. So this cannot be slowed down furthermore. Right. Write the definition. Okay, wait. Firstly, we have to write the definition of this one. Okay. Okay, guys. Now write the definition of vector. Of physical quantities with physical quantities with a magnitude and a fixed direction is known as what? Known as vectors. Sorry, are known as physical quantities with magnitude and fixed direction are known as vectors. Okay. So write the definition, and I have to tell you, whenever you are writing a definition in any subject, any stage of your life, use a specific symbol like a hashtag or a $sign or whatever specific symbol. Don't write without any specification or star sign. Why? Because we use star sign to imply what? Important points. In physics, definitions are extra important, extra special. Extra special to specify. I normally use these two symbols. You can use whatever, like this type of swastika symbol, whatever the special symbol you would like, right? I have no intervention with that. You decide and you do. Okay, guys? Right. This is what the definition. I think as now somebody who asked me, now I think you got the proper definition. No? You were just asking me for definition, so I gave it. So this is what physical quantity of a vector. Okay. Now write, and you already know what are the vectors and what are non-vectors, isn't that? So have a good look at here. Length, speed, time, volume, mass, energy, and those things are scalars. Why do we call it scalar? Oh, drop me a message. Drop me a message to my WhatsApp, and I'll share you the topic. Sorry. Drop me a message to this WhatsApp number, then I will forward the to you. Okay. Right. So why do we call length and displacement? I will explain the difference between scale and vector using length and displacement only. Have a good look at it. There are 2 points. One is point X and the other point is Y. Okay. I would draw a straight path like this. So see, the direction is always fixed. And you get a certain displacement of D. And the other way, I would look at how many directions are there. Millions of multiple directions are there. It is not a fixed direction. Millions of multiple directions. That's why we call this one as distance. This one as distance. Meanwhile, the other one as displacement. This one as displacement. Okay. Displacement is a vector. Why? Only one direction. Only having a one direction. Vector. Distance is a scalar. Why? Not only having one direction, there is a magnitude, like imagine 100 meters from here, but this is only 60 meters. See, both has the magnitude. This one has a magnitude of 60 meter. This one has a magnitude of 100 meter. But the problem is what? This one had traveled some 60 meters along with just one specific direction, only one direction. But this one changes. See, the direction is changes over the time. Can you understand? Direction is changing over the time. So that's the difference here. That's the difference. Okay, mark it. So actually in my regular class, I explained all these, like speed and velocity, time and acceleration, those things I explained. Now here, I have no intention. Might be you are still not familiar with these ones. Magnetic flux, no. Momentum, might not know. Torque, might not. Moment, no. And electric field, moment might be because some other teachers done this. Here also frequency or level thing, you might not know. You might not know this thing. You might not know. You might not. But just remember,
Just remember, that's enough. For this lesson, that's enough. And don't try to push these things into your head. Only remember 5 of these enough. They don't ask hundreds to write. Only 5 for the upcoming term tests. Then rest of the things you will automatically split into your head. ඒ කියන්නේ අපි බලෙන් ඔළුවට ඔබා ගන්න බැලුවොත් ජීවිතේට ඔළුවට යන්නේ නැහැ. අවුරුදු දෙකක් තියෙනවනේ. ඔය ඉබේ යනවා ඔළුවට. Let your brain to absorb slowly, steadily. Don't try hard, don't push hard. Right? Okay. Don't copy this even. Don't copy this even because you have these notes in your regular booklet. Okay. Now the importance is not like that. Vector notation is extremely important. Now write vector notation in your subtopic. Okay, vector notation as a subtopic, and copy this down to copy entire term down to your book. Until then, I will share the tute to those students who asked it for. Okay. Copy this vector notation quickly. Then I will. Oh, many. They need tute. There are 2 tutes. I'm going to share you both the tutes. Like 4 students ask for the tute. If there are any other one, then quickly ask me. I don't have time to waste. Okay, Butala. So, what is the vector notation? There are many ways to represent. There are many ways, but vectors are noted using this symbol. It can be a something like this with this type of semi-arrow about it. You can use any symbol, X and semi-arrow, or the same X with the full arrow, or so something like here. I marked it like from X to Y. No, where did it begin? Like I saw you, like I walked in front of the whiteboard. So that's why I told you, remember that. So I started to move from X to Y, right? I started to move from X to Y. So I can represent it like just writing XY bar, or XY again, that is not in this one, with an arrow. But how to write? I wrote like X to Y. If I want to write Y to X, I have to write it in the same direction, but with the negative symbol, right? I told you, I can't change the direction of the arrow. I can only change the point and point with the negative sign. Right? Okay, this is all about vector notation. I'm not going to spend more time in here. You know, you found really difficulty in not these areas. You found difficulty in resolution. You found difficulty in, so there are some students who can't still do projectile motion question. Why? They don't know how to resolve. They don't know how to resolve and get this component, Vy component and Vx component. All because of this, they can't entirely deal with what? Projectile. Projectile is a banned project for them. And for Newton's law, they understand the Newton's law, but they don't understand what? Inclined plane, because they don't know how did I just get this one as mg cos theta and this one as mg sin theta. They still wonder because they don't have proper understanding of vectors. Can you understand? Can you understand? So it is extremely important to know vectors from the point what I am trying to teach now onward. So far you saw the trailer. Now you are going to watch the movie, right? Now you are going to watch the movie, but this part is really essential. This part is extremely essential. And after copying this part, I am going to begin vector resolution. Those who were not in the beginning of the class, they might be thinking, this man crazy? Yes, I am a crazy. So I will start in the twisted order because this is the easiest way to give you the full concept of vectors, right? Don't write. Firstly read and take a screenshot and copy to your book, right? Representation of vector. I will explain you point by point to save our time. Vectors are represented by drawing arrows. The length represents the magnitude and the arrowhead indicates the direction. Okay, have a good look at. I am going to get the same example. A boy moved from X to Y, right? From X to Y, there is a direction. So that's the direction. I have to represent that direction with the magnitude by means of what? This length of the arrow. This length of the arrow shows you the magnitude. Meanwhile, this shows you the direction. Can you understand? Right. What is the next one? Vectors are added geometrically by placing tail of one vector head to another. And the resultant, don't write this. Don't write this because I am not going to teach you vector addition today. Today, I will teach you, but after the interval. Vectors can subtract it. Don't worry. Right? Okay. Only write this part. And this part. Don't write these two parts. And this part also. And these three diagrams really quickly. I will give you like 2 minutes. Maximum 2 minutes. දැන් ඔයාලා හිතනවා ඇති මෙයාකා මාර හයියෙන්නේ උගන්වන්නේ කියලා. මොකද මේ තවම මම මේක උගන්වන්න ගත්තේ නැහැ. මේ වැඩකට නැති දේවල් ටික මම ෆාස්ට් කරලා දානවා. I am explaining unwanted parts really fast, but I will teach you the wanted parts really slowly until you to understand, right? So now I am just giving you the extremely necessary but unwanted parts. If you are in my regular class, I took more than 2 hours to come to this point. I took more than 2 hours to come to this point. Those who were in my regular class, they know how long did I take. But this one, I don't want to. මම දැන් රෙගියුලර් ක්ලාස් එකේ ඉඳලා මෙතෙන්ට ආපු කට්ටිය කෙනෙක් ඉන්නවානේ කවුද අපේ සෙහත් ඉන්නවා. සෙහත්ට පොඩ්ඩක් අද තේරුන්නේ නැහැ කියලා කිව්වනේ. right සෙහත් can you speak up?
Yes, sir.
So how long did I take to explain this far normally in my regular class?
More than 2.5 hours.
Yeah, more than 2.5 hours to come to this part. But it was really unnecessary, no? Now the current lessons we are having like Newton's laws and we just concluded. And according to the lesson I'm just about to start, these are like really babies. Okay. Now your 2 minutes is just going to over. 9 seconds more. Okay, now let's start a real big thing you always find difficulty. Now write vector resolution. This is where you strangle your own neck. තමන්ගේම බෙල්ල තමන්ගේම අතින් හිර කරගන්න තැන ළමයි. So I will take longer time and explain you this one. Okay, copy this. Vector resolution. Vector resolution. Okay, why do we call it like vector resolution? Write this in a new line and write it is an important mathematical operation. It is an important mathematical operation to resolve a vector along a vector along two perpendicular components along two perpendicular components to each other, two perpendicular components to each other, two perpendicular components to each other compared to certain given angle. හොඳට හිතලා බලන්නකෝ. Just imagine, isn't this part makes you really uncomfortable in dealing with Newton's law calculations? ඇත්තටම මෙයාගින් ඒවා ඉර වෙන්නේ. If there is a vector like this, just a vector like this, how can I resolve? Now my slow mode activated. How to resolve? So what can I simply do is I am going to reproduce the same pattern here. I am going to reproduce it. See? Okay. Now what can I do is I can complete this as a triangle. I can complete this as a triangle. Right. This one is a perfect triangle now with the what? Right angle triangle. Perfect right angle triangle. Now what did I want to resolve it before? As I told you, I wanted to resolve it perpendicular to each other. This is along x-axis and this is along y-axis. This is how I wanted to resolve. Now what did I do? I actually removed this part. And implanted that part to here. That's what I did. Nothing else. So this one is what? Vy component. This one is what? Vx component. Now let me complete the diagram. And this is what? Vy, and this is Vx. Now we have to go for something called trigonometry, very basic trigonometry. There might be biological students who has only the understanding of trigonometry in their O level. If you don't understand this concept, just let me know by dropping a message. So vector resolution, Vy, and the other one is Vx. Let's see. Okay, Lamai. Please copy this one now. Take your time. Take your time and copy this one. Okay, lamai. I think I gave you enough time. I think I gave you really enough time. Now in this diagram, I am only going to consider one at a time. I remove this component. Now you only have this component and the main vector. Right. What is this side said in trigonometry? This is called opposite side. Opposite side. And this one is said the hypotenuse. Now there is a certain trigonometric ratio between the opposite side and the hypotenuse. What is it? That is sine theta. Sine theta equals to opposite side over hypotenuse. So in this case, sine theta equals to Vy over V. So by cross multiplying it, you can obtain the component of Vy is V sine theta. Copy this. V sine theta. V sine theta. Okay. I will give you another 10 seconds to copy this. You have another 10 seconds to copy. Right. Let's try it out for the other component. Now I took the vertical component and let me take the horizontal component out of it. Okay. Now let me erase this part. Now I only have one thing. What is this? This is the adjacent side. Adjacent side and hypotenuse again. What is the trigonometric ratio of adjacent side over hypotenuse? That's called cos theta equals to adjacent side over hypotenuse. What is my adjacent side here? Vx component. And what is my hypotenuse? That is the vector of V. Okay, let me get the result here. Vx equals V cos theta. Copy this. V cos theta. I know one important thing. You already know this one. This is not your problem even. How to apply this? That is your problem. Because at that time, you didn't ever expect what? Collisions. You didn't never expect projectile motion. You didn't never expect what? Inclined plane. You didn't ever expect friction. Nothing. Now you see the thing, but you don't know how to apply. Quickly finish this within another 10 seconds. Now, shall I tell you an Abhi secret? Abhi secret, Abhirahas of dealing with this one. There is one secret. Okay. So you always can't draw the triangle and find out the resolution. Again, or triangle and then the it is really horrible to you to draw the triangle all the time. It's in a ground like this, cricket ground. The cricketer hits the ball. Like today in the morning, Kusal Mendis gahuwa wage. Velocity is V. And there is an angle with the ground, which is theta. Which is theta. අම්මා සෙහට්ට මාර හැපිනේ කුසල් මෙන්ඩිස් ලකුණු ටිකක් තලා ගත්තාම එජ්ජලා ගිහිල්ලා හරි. මේ පොඩි බට්ටෝ ටිකක් දාලා දෙන්න ඕනේ ඉතින් පාරක් ගහන්න අලුත් එකේ හිටියොත් ඌ ගහලා දායි නැත්තම් ගහන්නේ. හරි. velocity is v. okay. මැච් 10ට එකක් ගහනවා මූට මාර හැපි. This is ground. Okay, how to resolve this? There is one secret. This one, you can see this one. See, this is ground and the vector. This side is closed. Closed. Vahila. Closed by the angle. So this is closed, no? The vector is closed by this angle with what? Ground. මතක තියාගන්න කෙටි ක්‍රමයක්. Closed. If the angle is closed, that is cos. If closed, that is cos. In this method, you can apply this to any level. So what is the component along the ground? Along the ground is V cos theta. Because why? That is the one closed. Other side is what? Open. See, this one is not closed by the vector. So it is open. Open is closed non cos, open non sin. If it is closed, it is cos. If it is open, that is sin. This is what? V sin theta. If you know this, keep this one as a mantra, like a chanting mantra. If closed, that is cos. If closed, that is cos. If you know this chant, you can solve any riddle. Let me explain you with one example. The most horrific for most of the students is this what? Inclined plane. You only have this, but you have to resolve all the forces. This is the secret. This is the secret recipe. Now you know the secret recipe and we can apply. Just copy that one. And I'll ask you to complete vectors in this one. I'll only draw this theta here. And this is mg downward. And I'll say another thing. this angle is also theta. I don't say why today, but I will only say this angle is also theta. Now resolve this mg into relevant components. Now, according to this mantra, what is this component, Lamai? Just text me instantly mg what? Mg what theta? Fill the space. Fill the space. Tell me the space, whether it is sine or whether it is cos. Complete. I need answers. Okay, Devmi said cos. Others. Tagala. Tell me the answer. Whether it is cos, whether it is sine. There is a space here. No, fill the space. Only Devmi send me the answers so far. Ramai, type the answer and send me, man. Okay. Ramai. I just need to know one thing. Couldn't you understand this one? Couldn't you understand this ground and the vector thingy that I explained with the close side thingy? If you don't understand this close thingy, just ask me again. This is the easiest way because you can't draw vector triangle all the time and find out. You should know something really simple. Yeah, Amana, right? Others? Asna, yes. Chalaka, yes. බය වෙන්න එපා වැරදි අයගේ මම නම කියන්නේ නැහැ හරි අයගේ විතරයි නම කියන්නේ I only say the name of the right guys not the wrong ones ළමයිනේ oh my god වැරදි it's wrong not fine okay I said the answer now I said the answer somehow so it's my bad so that's cos because why have a really good look at here first of all let me know is there anybody who couldn't understand this clause law if you didn't understand this clause thingy you might not be able to do that stuff right okay this is what cos theta I told you the other one should be perpendicular with this one the other one is sin theta okay I'll give you another one this one you might found really recently in your one of your main classes there are boxes like this and you put some force on it the force with the magnitude of F right now resolve I will only say this angle is theta I will say this angle is theta now I need you to resolve this force one along horizontal the other one along vertical what is the vertical component what is the horizontal component tell me how to get this horizontal component and vertical component let me know how to get these components vertical and horizontal okay I'll ask what is this vertical component fill the vertical firstly now I'm asking what is the vertical component I'll only have to draw this vector, that of f here, that of f here, vector that of f here, and the angle here it is theta. Angle here it is theta. Right. So how to get this component? The vertical is this one, f vertical. This is what my f vertical. As I told you in the previous page, no, actually in this page, I told you when the angle is covered, that side is going to be what? Cos theta. So what is this vertical thingy then? What is this vertical thing now? What is this vertical thing now? That's the closed side. Angle is closed there. I told you if the closed angle is closed with the side, closed equals to cos. So this is going to be f cos theta. So the other component, as I told you, it should be perpendicular with this one. So the f horizontal one is the open side. So that is f sine theta. So this one is really important aspect in dealing with what? Friction. During dealing with friction, you might have found hundreds of these applications. Okay, now I'm going to do with the opposite of the previous case. At least for this one, send me your own answer. Don't wait for mine. I'm going to drag this with the force of what? F. This is what my F vertical horizontal component. And this is going to be my F vertical component. Now these both are spaces for you to fill. And there is an angle of theta between. Now tell me the answer at least for the horizontal. My answer is, I'm expecting you to find out the answer for F horizontal. Tell me the answer. Quickly type and send me. Quickly type and send me. Only the type is enough. Right? Whether F cos or F sine. F cos or F sine. That's enough. Okay, I got 4 answers. All are correct. Tamai, I need a horizontal component, whether it is cos or sine. Formula, I only got 4 answers so far. Okay. Have a good look at. The vertical one is the one being closed with the what? Vector. This vertical, sorry, horizontal one is the closed one. I told you again, if the angle is closed, that is cos. So this is not a mathematical concept. This is not a mathematical concept. Something to you to easily understand. Remember, because you always can't draw this vector diagram and find. You should know how to get it. So this cross side is the f cos theta. This open side is the f sine theta. You can easily approach and get the answer. Okay, I explained you in very different and multiple ways. If you want to copy any of these, copy now. I will give you like 1 minute point, because you might not miss all. You might miss only 1 or 2. So copy. Okay, Lamai, done this. I'll just keep this for 1 minute. Okay, if you have done copying that one, come back to this point, this new tute. If you didn't get this tute, drop me a message to my WhatsApp. Then I'll share you the tute again for anybody who doesn't have the tute. Now let's go for the resolution of vector tute. I just added all the resultant force and how to get the right angle to each other thingy with full explanation. I gave you the explanations today itself. Now you find different things like this. So examples are done here. See, horizontal component and how to get this all. Okay. 2 examples first 2 has done for you. Now let's try the rest of the 4. Let's try to do very simple exercise here. If anybody doesn't have the tute with you, just let me know. Okay. I'll give you like for one more than 30 minutes, 30 seconds is more than enough. If you don't know, if I give you 30 minutes for each, you don't do. So 30, 1 minute, 2 minutes. Maximum time allocation is 2 minutes. Maximum time allocation is 2 minutes. Right, let's start. Maximum time allocation is going to be 2 minutes from here. Okay, Lamai, let's see how. This one is directly given the angle and everything. You can easily deal with it. But here, the angle is here. This is why my vector is a velocity thingy, 130 meters per second. And now I'm going to close my angle. The side which is get closed by this east thingy. What is this? 130 cos 25 is my component at here. This is the open side. 130 sine 25 is the answer for this one. Now here you have to do something, and I want to check that one whether it is yeah, it is east. Yeah, it is east. Relative to east, 22 degree relative to east. Okay. According to this diagram, it doesn't show like that. It shows like, wow, it's like that east. Wait, let me check again. Yeah, it says east. According to this scale, it shows like some 20 degree here, but it doesn't matter as it instructs you. At some 22 degrees to east. Yeah, 22 degrees to east. Yeah, this is what 22. See, this is east. This is at north. From north, 22 degree towards east. Isn't that? From north, 22 degree towards east. That's how it says. The angle is here. Understand? From north, at 22 degree to east. Right? That's how it says. This is what my angle theta. I'll just mark it like theta. This is the close side. So what is it? 300 cos 22. This one is 300 sine 22. Okay, it says 12 meters at 60 degree of east. This one said like to east. This is like at east. වචනවල වෙනස තේරෙන්න ඕනේ. This is what 60 because of east. Other one is at east. To east. This is off east means this angle 60. So what is it? 12 cos 60. This one is 12 sine 60. How about this? This one is already given 77.4. Angle is given. This is what the cos component 77.4 cos 70 cos 79, and this component is 77.4 sine 79. These are the answers that I can have from here. Okay, very simple ones. Okay, now kind of, so we can't go for this part yet because I have to teach you a thing called what? Vector addition yet. I didn't say anything about vector addition. I only taught you the vector resolution. Now only try this one and this one. These two questions. I'll give you like four minutes because there are 4 questions asked, 4 sub questions asked. So 4 minutes for you. I'll allow you like 4 minutes for you. Within 4 minutes, right? If you don't have the tute, just ask me. Okay, I gave you enough time. Let's discuss now. A boy pulling a toy car with a force of 6 Newton as shown in the figure below. So find the horizontal and vertical components of the force. This is what 6 horizontal you get, and this is what 6 vertical you may get. So let's find. 6 horizontal is what? What is the horizontal component of 6? So this one is the one in cos. I told you again, I'm repeating. Cos means cos 6 cos 30. Leave it like that. Don't solve it out. If you only need just like what? Cos 30, no? Root 3 over 2. And get it like what? 3 root 3. If you only need. Otherwise, don't need. And the other one, 6 vertical. How? 6 times sine 30. That means 6 times half, like 3 Newton. Or leave it as this way. Whatever, it doesn't matter. I just need you to understand the component, how to resolve along horizontal, how to resolve along vertical. That is what my primary thing I need to know. Primary. Okay. Now, Baggy pushes a 250 kg roller on the floor with a force of 200 Newton from the handle. This is what I need to find out. 200 horizontal component and 200 what? Vertical component. This is what find the vertical and component of the first. F horizontal is what? This is what here the angle is crossed by this one. 200 cos 45. Just leave it like that. And the vertical component is what? 200 sine 45. You may get the same answer for these two. What is the weight of the roller? Weight. We know weight equals to mg. What is m? 250 times 10, 2500 Newton downward is the weight. What is the total downward force on the ground? Let's resolve this one and find out the answer. 200 into 1 over root 2. So root 2 means I can write it like here. Root 2 times root 2 times 100 as 200 and root 2 cancel off. So this is like root 2 times 100. We know the value of root 2 normally is like 1.41. So what is my answer is going to be? 141 Newton is the downward force. 141 Newton is the downward force provided by pushing. So what is the total downward? F total downward is what? Weight plus F vertical, because both are downward. So weight is like 2500 and the other one is like 141. So 2641 Newton downwards is the total force is downward. Try to copy this one. Another 20 seconds for you to copy. If you didn't do this one, another 20 seconds for you. Okay, now I'm going to give you something really important. Now let me know one thing from all of those students. Have you ever began to learn momentum so far in your classes? Momentum in your current classes? Have you ever began to learn momentum? Ramai, please let me know whether you have learned like the momentum thingy. The object collide and bounce back. Collide and bounce back. Yes. Okay. Fatima. So did you obtain any change of momentum, delta P, so far? Delta P thingy. Yeah, good. Delta P is nothing other than final momentum minus initial momentum. Yeah, yeah. So this one is in M and moving at the velocity of U here, right? And it bounce back and reflect against of the surface with the same angle. I may just mark it like with the same angle. This angle is theta. This angle is theta. And after hitting against the stuff, it might have a different momentum now, moving in the same but opposite direction with the same mass, but with a different velocity of v. Okay, I'll consider like this one is also u. This one is also u. And I'll give you some detail about momentum. P equals to mv. Right? Here in this case, P equals to mu because both cases u. Now I need my question is find out what delta P along horizontal axis. Horizontal axis. That is what my question. Try to find out an answer. This is the area I know that most of the students find something really bizarre answers. Ammutu vikara answers ganna. They find some really different answers. Okay, I will give you 2 minutes. If somebody knows how to do it, they know how. If they don't know, these 2 minutes feel like 2 years for them. If somebody knows, these 2 minutes will be more than enough. Okay, try this and send me the answer. No. I need delta P, total change of momentum. That means the final momentum subtracted by the initial momentum. That's why I need. Recording in progress. Okay, guys. Let's see. Now tell me what is delta P? Answer. Yeah, Fatima, really good. Yes. Really good. Fatima's answer is really good. Others? Now you have to resolve this one. I am going to make a what? Simple trick along this one. Why? For only for this one. Why? The vertical component, horizontal component, this is the same angle theta repeating here. Why? Alternate angles. If this one is mu in that direction, this is going to be mu cos theta. And this is mu all along this direction. This is going to be mu cos theta as well. This is what the final momentum Pf. This is what the initial momentum of Pi. Right. What do I have to apply it is here is delta P equals to Pf is what? This one. I'm going to consider the final direction as the positive one. And the initial direction should be the negative. See, in this manner, we can easily apply final decision. I told you, if I choose certain direction as my positive, I can't change the direction of the arrow, but I can change it with the negative sign and apply. Can you remember? I was walking along in front of my whiteboard to this direction, and I walked back in the other direction, keeping my head to the same direction. Can you remember that? But I couldn't change the direction. I could move reverse. So this is what mu cos theta minus change of always final minus initial. In the initial component, it is also mu cos theta minus it has a negative sign. Why? Because it is moving in the other direction. Mu cos theta. Now what is it going to be? Mu cos theta and minus becomes plus mu cos theta. So what is the total momentum now? Change of momentum. 2 mu cos theta. Understand? These are the areas you find difficult in present day. Okay, I thought you think you have enough time to copy this. Now can you understand how essential my teaching method it is? I told you I'm going to spend like 30 minutes on just revising the very basic theory and step into the vector resolution, because I know the vector resolution is the most wanted thing now, not vector and this unnecessary theory here. So see here in this one, I just keep adding, and even grade 10 students know how to add in the same direction. We can add. There are some theories behind this combining vectors and the opposite direction. These are really babies. And the vector triangle, see, these ones are really babies. See, these ones now you can do with nothing. That's why. So the laws, the special points to remember: equivalent vector, right? Parallel to each other, similar direction, equal magnitude. This one are already digested to you now. Negative vector. Negative vector I show you in the physical appearance. I walked in the one direction to my right hand side and I just returned without changing my face position. So that's the negative direction. So see, we can't change the direction. We can only say what? A to B, C to D, but negative BA. CD, you can't write it like that. So what can you do? So AB and CD is what? From B to A. See, B to A is the returning way, but you have just keep your face in the same direction. You are reversing your vehicle now. That's why I added negative sign. I just explained all these. No need. Now write vector parallelogram theory. By the way, let's get like 10-minute interval and learn the vector parallelogram. I think that's going to affect because I did like a really rushing work now. Your heads might be less feeling like exploding now. So let's get like maximum of 10 minutes. No, 15-minute break, 15-minute magam, right? Let's get 15-minute interval and join back. So now the time is like 4:16, exactly like 2:30. Right. So keep your devices muted and take your interval. I'm also taking my interval. Now the timer is clicking. Okay, let's get an interval. Okay, guys, I think you heard because I don't know from what group you are coming from. Normally, I'm just putting a message even. So let me confirm that whether you heard it. Hi there. Are you there? Lamai, are you there in the meeting? Yeah, good. Hmm. Okay. Okay. So now it's about us to learn vector triangle, and I will just explain you equivalent vector and negative vector really quickly, right? Just quick explanation, not like a proper note here. I'm not giving any note at this case because there are thousands of important things to be done. Not this type of shitty stuff. Okay. Now have a really good look at here. An equivalent vector. There is a vector which is what? A, B. From A to B. There is another one which is C to D. The first law is what? Equal in magnitude. So AB should be equals to CD. That one is already assured here. AB is equals to vector of AB equals to CD. The next thing, okay, there are two vectors. One is here, AB, X.
But there is another vector y with the same size, but in a different direction. So technically you can't apply, right? You can't apply. So the vector should be really important. Parallel in each, AB is parallel to CD. Now the next part is similar direction. Okay. There might be a vector of x to there. There is another vector in the same size, parallel, but in opposite direction. Is that an equivalent? No, it's not equivalent. So it should be even magnitude, parallel to each other, and in the similar direction, AB and the CD. Then they are supposed to be equivalent vectors. So what is the negative vector? Suppose a vector given like the magnitude. Okay, let me draw a line like this. I'll mark this in the direction. This one has the positive direction. This one is my positive. This vector is A. From A to B. From A to B. Now I'm going to copy a similar vector. Similar size vector, which is parallel. Everything is similar, but only one thing is different. What is it? You can't change the direction. I told you, you can't change the direction. A is there and the B is there. Now actually the vector is lying from what? Starting from B to A. Now this is what? AB vector. That's simple A. There is a vector B. That is what? From B to A. Now I am going to mark it, but from B to A, but the arrow should be in the same direction. The arrow should be in the same direction, but the vector which is now reversing, in the previous one, it ran from A to B. Now this one running from B to A, but keeping your face in the same direction. You are not changing your face. So what is it? AB here equals to BA. So I can write it like negative BA. A equals to minus B. This is how you take it. A equals to minus B, because you have to get the match arrow direction back into the positive direction, because you can't change your face, and the only thing you can do is you can reverse, but you can't. Okay, it's like that. Imagine a condition. You are just driving your vehicle in a certain path. It is covered by two walls. This size is just enough for your vehicle to move forward. But all of a sudden, there was a junction here. You missed that. You have gone somewhere here, and you can't turn. What is your only option? You just need to reverse the vehicle and turn, because you can't turn your vehicle the face to the other direction, because why? There is no space. It is as same as of this condition. In a vector system, you can never change the direction of the arrow as a convention. Once you consider certain direction as positive, other direction is opposite of that. That's something like a very known theory, well-known theory. Yes, I took BA as minus because it's direction, because I have to keep the same direction, but it is moving in the opposite way. To express that, I put the negative sign. See, now AB, same size, BA, parallel, but AB and CD effective directions are opposite AB. And now this is moving from D to C, but the arrow is the same. Now I'm representing certain arrow, but actual arrow is in the opposite way. So to represent that, the direction of the actual arrow, I have to put a negative sign. Understand? Okay. And the zero vector, null vector, these are really, even I didn't teach any these two in my regular class, even I just asked them to read. Okay. Vector triangle and vector parallelogram, sorry, vector polygon is to be done in the next day. But today, I am going to teach vector addition of parallelogram wheel. This parallelogram theory. So, write a big topic, vector parallelogram theory. Vector parallelogram theory. Okay, you know how to add this. When there is a vector of 5 Newton and there is a Newton, 10 Newton, what is the resultant? You may draw it like this type of line as the resultant. Resultant equals to 10 plus 5 and write it like 15 Newton. This one you already know. But if two vectors are marked like this, one is here, other one is here, how to get the vector? Resultant. You know that the resultant is lying between here. This is P and this is Q. How to find out R? This is what I am going to teach you. The resultant. The resultant vector. How it is going to be. How it is going to be. Okay, Lamai, let me just teach you now. Okay. Now this is my resultant here. Right. Now I don't know how to get the resultant. This one is it. This is my P vector. What's wrong with this? This is my vector P and this is my vector Q. I want to find out the vector of R. I want to find out the vector of R. How? How? So I can do a very simple thing. I can reproduce the same vector back again and keep it at here. I can reproduce the same vector, parallel vector back again and keep it on top of it here. What does it make now? It has produced me an amazing result that of what? The same PQ here and same P here. And there is an angle between these two. That angle is what? These two is theta. I get it like theta. Now I will mark it like A, B, C, D. Okay. 4 sides of ABCD triangle. Okay. Understand? So let me get it here. So write it. When there are two vectors, write it. Then when there are two vectors acting on a point, making an angle of theta, between them. as in the diagram given below. As in the diagram given below. The resultant vector can be represented as following. Resultant vector can be represented as following. First, you draw this diagram. Wait. Don't draw the resultant now. Just draw this diagram. And let's guess the resultant like this. Okay. Now copy both the diagrams. Copy both the diagrams. And you know what? Actually, you don't want to know the theory behind this and derive this. Because in no question, they ask something silly like this. They never ask a question as silly as like this. They don't want. Right? They don't want to test your knowledge with such a silly question like this. So, but as a basics, I will teach you how to obtain. If you don't still know, don't waste your time on learning that. Only know how to apply. Okay? Only know how to apply, that's more than enough. So, write this. The diagram can be completed as following into a what? As following into a parallelogram. Following into a parallelogram as given in the diagram below. Into a parallelogram as given in the diagram below. And don't draw. I can complete and keep your space to draw this one. So this diagram. In my regular class, I gave enough time. But here, no need. Now, right, keeping some space. And the line AD can be extended up to E. Up to the point E. Up to the point E to obtain what? Up to the point E to obtain up to the point E to obtain what? The point E to obtain ACE right angle triangle. ACE right angle triangle. Now take a screenshot. I will send you the PDF of today's drawing, but I don't know from what group you are. Take a screenshot of this one and roll it. Now let me see. And actually you don't need, because in my tute I included all these in the theory. See? I included this all, see, parallelogram law completely included here. So actually you don't need. If you only need, copy. Now let me erase the unwanted parts from here. I'm erasing out unwanted parts. So let me do a repair work. Let's see. Okay. According to Pythagoras theorem, we know that R square equals to P square plus Q square. You know. So now here, what is it? AC square equals to A E square plus CE square. Now from this triangle, from this small triangle, this is theta, this is P, this is Q. So what is this? Q sine theta, this is Q cos theta. I taught you today, just only today. That's why I taught that part earlier. This Q vector can be just got to what? Q cos theta and Q sine theta. Right. Now my triangle, I can finish it like what? Q cos theta and this part like Q sine theta. What is AC? This one is nothing other than R. R square equals to AE is what? P plus Q cos theta square plus this part is Q sine theta and square. So finally, I may get a result like this. R square equals to P square plus so what is it? Q square plus 2PQ cos theta. Sorry. Q squared cos square theta plus 2PQ cos theta plus Q squared sin square theta. Okay. P square I can write, and here Q square out and cos square theta plus sin square theta plus 2PQ cos theta. What is it going to be? This is 1 according to some mathematical approach. I also mentioned that thing here. The basic trigonometry. From basic trigonometry, this part cos square theta equals sin square theta equals to 1. I include all in the theory. So my R square is going to be P square plus Q square plus 2PQ cos theta. This is what your primary knowledge you want to know. Actually, I'm stressing you, don't copy this one because this is irrelevant. I show it only for some reason because I thought if you know this one, it's going to be helpful. But applications are really different. But mostly you get in real applications, mostly in momentum and other things, like this. You get one as P, other one as Q. So wait, mama, take a mark. Q and P like this. These are perpendicular to each other. You have to find out R. If I write the equation R square equals to P square plus Q square plus 2PQ cos theta. Now have a good look at what is cos 90 here. Theta is 90 now. Cos 90 is 0. So you can cancel off this whole term and write it like only for P is perpendicular to the Q, R square equals V square plus Q square only. Right? This is really an essential result that you have to obtain from it. And also from the triangle, this exact particular triangle, you can get another result. What is that result is going to be? Let's see. What is that result is going to be? You can find out the angle of alpha. What? Angle of alpha. This one, alpha. What is this alpha? You can get the tan alpha. These ones you already know. How can I write it? Tan alpha equals Q sine theta over P plus Q cos theta. Using this one, you can find out the angle of the resultant with any of these basic components. Here also you can apply that rule, but P and Q and what? This thing, R. This alpha, how to get? When theta equals to 90, sine theta equals to 1 and cos theta is equal to 0. Apply this to here. This sine theta to there and cos theta to there. You get what? Tan alpha equals to Q over P only. These are the knowledge you just need to know. Nothing else. Now guys, let me know, could you understand all of these about the vector parallelogram theory? If you didn't understand this part, don't worry. If you didn't understand, don't worry. No need. If you understood this one, and this one, that's more than enough. Tell me whether you got it or not, quickly. If you don't understand any of these, just let me know. Because after Newton's law of motion, you will have to use these three results frequently, all the time. Let me know. ළමයින්ගෙන් සද්දයක් නෑ ළමයි මොකද ඔයාලට වෙලා තියෙන්නේ Okay, let's go for practical application then. Then let's try these 4 questions quickly. In the page number, no. Those are in page number 14. Try these quickly. Page number 14. Done. Right, good. Said done. Whether a track athlete runs 3.5 laps around a circular track. The track has a circumference of this much. Find the distance traveled during its run. This is a circular track. He has to complete what? 3.5 laps. If he started here 1 lap, 2 lap, 3 lap, and 3.5 lap. Circumference is like what? 0.2 10 to the power 2. Right, 0.2 10 to the power 2. That means the circumference. So the distance is 3.5 times 0.2 10 to the power 2. Right. It's like what? 7 and 14. 14 into 10 to the power 2 meter is the distance he has run during his process. But the displacement is what? From this point to here is not the, it's like the scalar quantity. This is the vector quantity. So it is what? Diameter. How to find out the diameter? We know circumference equals to pi d. Pi d. So it's like 4 into 10 to the power 2 equals to pi times d. D equals to what? 4 into 10 to the power 2 over pi. Pi we can take it like 3 for our convenience. So it is like mostly 1.33 into 10 to the power 2 meters, like 133.3 meters. Very simply. Okay, a force of 10 pound acts north and 20 pound acts south. This is 20 pound south and 10 pound north. So what is the total resultant force? This is downward. There is a resultant like what? 20 to down plus 10 also down, but with the negative y. I took in the other direction. So the resultant is like what? 10 pounds downwards. And the other one. A jogger runs 3.0 into 10 to the power 2 meters due east. 3 into 10 to the power 2 in due east, then turn meters to due south position. Due south. This asks, what is the total distance? Distance is what? 3 into 10 to the power 2 plus 5 into 10 to the power 2. So this is what the distance, but the displacement is capital D. I will take capital D is what? It's like a right angle triangle now. In a right angle triangle, how to get it? 10 to the power 2 square plus 5 into 10 to the power 2 square. What is it going to be? 9 into 10 to the power 4 plus 25 into 10 to the power 4 and the root. So mostly I'll get it like 10 to the power 2 out and root 34. Leave it like that. Now in the next one, a plane flying due north at this March encounters wind blow, then due south 45 miles per hour. Determine the plane's resultant velocity. North to 200, south 45. So what is it? The resultant velocity is going to be 200 upwards minus 45 downwards, because that's why I put the negative sign to there. What is my velocity completely upwards? It's going to be 155 miles per hours. So this is a really simple question there. Not included vectors. Let's try these four. Let's try these four quickly. In the page number 15, 10, 11, 12, 14, 13. Start. Okay. Now it says a bird flies at 12 miles per hour to due west, and while at the same time a wind blows at the bird at 4 miles per hour in the direction 30 degrees to the northwest. Okay. So he flies at what? West. At what? 12. While the same time a wind blows the bird at the direction of 30 of west. 30 of west. Here. North of west. 32 north of west. North of west means this is 30. So it is like some 4 miles per hour. What is the resultant? Resultant. So how to find out this thing? We have the equation like of what? R square equals to P square plus Q square plus 2PQ cos theta. That is what my equation. R equals P is 12 square plus 4 square plus 2 times 12 times 4 times cos 30. And apply and 144 plus 16 plus 12 times 2 is like, what is it like? 24. 24 times 4 is like 96. Times cos 30 is root 3 over 2, and it's like 48 again. 48 root 3, like 160 plus 48 root 3. So find it later, no need to worry. And wait. And another thing, how to get the square root of this one, all of it. First to get that, you have to get the square root of it. Another plane heads 60 degree of north of east. This is east, 60 degree. To the east at 200 meters per second. And the wind blows 60 degree to the north of east. 60. So this one says what? A plane heads 60 degree of north, 60 degree north of east. This is 60. Wind blows 60 degree of 60 degree north of east at 50 meters per second. That's the same thing. North of east, same angle at 50. What is it? So in this one, nothing. You just have to add because it's the same direction. 200 plus 50, it is 250 meters per second. It's all to distract you. North of 60 north of east means the same thing is the same parallel. The parallel means you can add equivalent vectors, not equivalent, but same direction. A boat heads upstream with what? Upstream with velocity of 40 meters per second at an angle of 45 to north of east. It is moving at south, 10 is minus 1. This one moves at what? 45 degree to the upstream with west, like 45 degree to the north of east, some 40 meters per second, and this is to south. Okay, so this one we have to firstly resolve, right? Firstly resolve and obtain an answer. Also, we can get the answer like so this way. It is here 40 and this is 90. 90 and 40 is what? 130 degree apart. The resultant could be somewhere here. You can apply the same way. P is what? 40 square plus 10 square plus 2 times what? 40 times 10 times cos theta is cos 130. Just leave it. And the square root. You have to get the square root of 1. A man driving a car exactly is 500 meters due west from line marking on the eastern zone. Eastern time zone. Due west from a line marking on eastern time zone. Eastern time zone is here. 500 meters to due west. And he enters 30 meters per second along the straight road and runs direction 30 degree of northeast. 30. How much time does it take to man to go to eastern time zone? It is what? He travels 30 meters per second along a straight road that runs direction of 30 meters north of east. His speed is 30 and the angle is also 30. So what he needs is this velocity component is horizontal velocity component is what? From here 30 cos 30. 30 cos 30 is the velocity component. So what is the horizontal component? 30 times root 3 over 2. You will get it like 15 root 3 is the velocity component. Now you have to cover up a distance of 5,000. We know velocity distance equals to distance over time. Time equals to distance over velocity. Distance is 5,000 meters. Divide by 15 root 3. Using this one, you can easily find out the time. Okay. Is there anybody who can't understand this? Okay. My major aim is not the things I taught today my major aim is to do this worksheet. This is what the heart of vectors. See, this question also looks like really simple, sometimes really terrible because decimal values are there. But there is an MCQ technique over here. For dealing with MCQs, you have to use your superpower in your brain. This one also, this looks really, even this question is the most important out of it, right? It's such a simple technique, but people take like millions of years to solve this, but you can do it within less than 30 seconds. See, this is my major task, and I know that the people, when they happen to see this type of diagram thingy, vector diagram, they just struggle. They don't know this type of one. They think this is the heart of vector. No. In the vector lesson, this is the heart. But in the real calculations like Newton's laws and momentum, vector resolution and the vector parallelogram is the heart. Right? So that's why I taught you vector resolution thingy. You will get this type of questions. Even though I may not get a big fan base, I take the real thingy. If I started to teach very light way, slowly, and very simple things, might be there will be more crowd than this remaining, but it's not satisfiable for me. I normally need to do the real thing and get a really high result and let my results to speak up. So that's why I took a different way. So in vector class, they think this is the hardest. So to impress those people, in the next week, I will teach all of these and including what. So these type of questions, there are students, they still don't know. So I will teach that, including this type of Newton's law ones and the real applications. I made another tune with Newton's law and momentum, real applications of vector. These are the things I'm going to do in the next week. And another thing I have to show you, another thing that means like the vector parallelogram, vector triangle thingy. Okay, vector triangle thingy. Vector triangle also, I include a certain worksheet here. We are going to do vector triangle within like 20 minutes, 30 minutes, and finish the entire tute of this one. And this vector finalized worksheet, and in the last, actually not in the last, actually I should start that in the first hour. First hour, I'm going to do that special worksheet. What is that special worksheet? Applications of vectors in Newton's law and momentum. Applications of vectors in Newton's law and momentum. That's going to be the first hour thingy. After that, I will teach vector triangle and the final worksheet, and the vectors are to be done in the next day within 3 hours. Okay. So let's wind up the class for today. God bless you guys. Okay. I think it's time to wind up the class for today. God bless you guys. Bye.